Good morning, dear student. In today's lecture, we will discuss the next point of catalysis, that is the difference, that is the different types of catalysis. One is homogeneous catalysis and second is heterogeneous catalysis. So we will discuss one by one the distinguishing point between homogeneous catalysis and heterogeneous catalysis. Okay, so let us see what is homogeneous and heterogeneous catalysis. Homogeneous versus heterogeneous catalysis. Homogeneous catalysis versus heterogeneous catalysis. So what is the difference between homogeneous and heterogeneous? So the meaning, the word itself indicate homo means same and hetero means two different. So let us see the first distinguishing point, that is in homogeneous catalysis the reactant, that is your substrate, and your catalyst are present in same phase. So both catalyst and substrate in same phase, So in this case, for heterogeneous catalysis, hetero means two different. So catalyst and substrate are in different phase. So they are in different phase. Catalyst and substrate is in different phase. So this is the first distinguishing point. Its meaning is, let us consider the second point. Its meaning is the catalyst is soluble in reaction mixture. So they are soluble in reaction mixture. So solubility. So second important distinguishing point is that the solubility of catalyst. So they are soluble in reaction mixture. Soluble in reaction mixture. Soluble in reaction mixture. So this is a second important point, solubility. So both catalyst and substrate in same phase. In this case, it is in different phase. Second point is they are soluble in reaction mixture. Here they are insoluble. They are insoluble in reaction mixture. So this is the second important point. So soluble in reaction mixture, insoluble in reaction mixture. Next important distinguishing point for this homogeneous and heterogeneous catalysis, let us see its activity and selectivity. Activity and selectivity is very high. So this is the third point. So in this case, the activity and selectivity is less. So this is the important distinguishing features between this homogeneous and heterogeneous catalysis, that the activity generally expressed in terms of catalytic efficiency, and the selectivity, we already discussed selectivity, that is chemo, ratio, enantio, diastereoselectivity. So selectivity is very high. So we get a particular product, in desired amount, that is nothing but the selectivity of catalyst. But in this heterogeneous catalysis, the activity and selectivity is very less as compared to this homogeneous catalysis. Let us see the another important distinguishing points for this homogeneous and heterogeneous catalysis, that is the next important distinguishing point is that the reaction mechanism reaction mechanism reaction mechanism is well understood is well understood. So in this case the reaction mechanism is complicated. Reaction mechanism is complicated. So in homogeneous catalysis, whatever the reaction which is carried by homogeneous catalysis, the reaction mechanism is well understood. So what is which kind of reactions which is involved in this mechanism is well understood, while in this case the reaction mechanism is complicated. So we will discuss one by one what are the different catalysts for homogeneous, what are the different catalysts used as a homogeneous catalyst. So this is the important distinguishing point, that is the reaction mechanism is well understood, so we can easily study the catalytic cycle for homogeneous catalysis as compared to this heterogeneous catalysis. Next important distinguishing point is that it is expensive. It is expensive. It is economical. No doubt, its selectivity and activity is very high. Reaction mechanism is well understood. They are in same phase. They are soluble in reaction mixture, but it is expensive, very costly as compared to this heterogeneous catalysis, which is economical. Okay. Next important point, that is the separation of catalyst and product is very difficult in this homogeneous catalysis. So separation of product and catalyst is very difficult in this case. The separation of product and catalyst is very difficult in homogeneous catalysis, while the separation of product and catalyst is very easy. So separation is very easy. Separation is very easy. So these are the important distinguishing points regarding to the homogeneous and heterogeneous catalysis, that is it is expensive, it is economic. Separation is difficult, separation is easy. Okay, so these are the important distinguishing points regarding to the homogeneous catalysis and heterogeneous catalysis. We are very much interested in homogeneous catalysis. So let us see one by one what is this homogeneous catalysis. So the first point in homogeneous catalysis is that the first important point in homogeneous catalysis is that is the system. So we can write here homogeneous catalysis system. Homogeneous catalysis systems. So what are these homogeneous catalysis systems? So let us see one by one. So there is several catalysis system. One by one we will discuss. The first one is catalysis by acid and base. So catalysis in presence of acid or base, it is considered as catalysis by acid base. So it is one of the system of homogeneous catalysis. It is one of the system of homogeneous catalysis, that is catalysis by acid or base. So the simple example of this catalysis of acid based system is the hydrolysis reaction of ethyl acetate. So to perform the experiment in SYBSC, that is hydrolysis of ethyl acetate or methyl acetate in presence of acid as a catalyst or in presence of base, that is acid catalyzed ester hydrolysis or base catalyzed ester hydrolysis. So this is the example of catalysis by acid or base. So we can write here example is, that is hydrolysis of ester. This is the first example, that is hydrolysis of ester, that is catalysis by acid or base. Simply you have to use acid or base to catalyze this reaction, hydrolysis of ester. So ester is converted into acid and alcohol. So the second important system is that the catalysis by metal ion or metal atom, catalysis by the metal atom. So metal atom is used as a catalyst for conversion of reactant into the product. So this is the second catalytic system, homogeneous catalytic system, that is catalysis by metal atom. The example of this catalysis by metal atom is, we already discussed this example in selectivity, that is oxidation of olefins in presence of silver as a catalyst to get oxirane as a product. So oxidation of olefins in presence of silver as a catalyst to give oxirane as a product. So this is the second system, that is catalysis by metal atom. So different metal atoms are used as a catalyst in homogeneous catalysis system. So let us see the next, that is third system. So first, that is catalysis by acid or base, second catalysis by metal atom, next that is enzyme catalysis. So we already discussed about enzyme catalysis in first year. So enzyme catalysis, we know that simple reaction, that is enzyme plus substrate gives enzyme substrate complex, and this enzyme substrate is converted into the product. So with the help of enzyme you have to convert this substrate into the product. So enzyme catalysis, it is also one of the homogeneous catalytic system. So this is the third homogeneous catalytic system, that is enzyme catalysis. So with the help of enzyme you have to convert the reactant into the product. Okay, enzyme plus substrate gives enzyme substrate, and enzyme substrate decompose into the product. Enzyme catalysis, we already discussed about the equation for enzyme catalysis. Okay, then the graph for this enzyme catalysis, that is Lineweaver-Burke plot or Edi plots. So this is also the homogeneous catalysis system. Let us see the next one, that is catalysis by organometallic complexes. So we are very much interested in this system, that is catalysis by organometallic complexes. So organometallic complexes means what? There is a metal atom, and these metal atoms are attached to different ligands. So these organometallic complexes are used in reaction to convert the reactant into the products. So catalysis by organometallic complexes. So organometallic complexes, we will see which are the complexes used as a homogeneous catalysis in this system, that is catalysis by organometallic complex. So metal atom attached to the ligands are used as a catalyst for this homogeneous catalysis system, or it is also the important system in homogeneous catalysis. So catalysis by organometallic complex. So we already discussed the different types of inorganic reaction, that is oxidative addition, reductive elimination, 1,1 insertion, 1,2 insertion, beta hydride eliminations. So these all reactions are involved in this catalysis by organometallic complexes. So whenever a organometallic complex is used as a catalyst, all these processes are involved in catalytic cycle. That is, we know that oxidative addition is the first step of any catalytic process by using organometallic complex. Reductive elimination is the last step of catalytic process. So oxidative addition, reductive elimination, 1,1 insertion, 1,2 insertion, beta hydride elimination, coordination of ligands. So these all are the steps, or all are the steps, or all the reactions are involved in this system, that is catalysis by organometallic complex. Also, uh, if we consider the example of these organometallic complexes, so there is a lot of example of organometallic complexes we will study one by one. So here we consider only the example. The first example is rhodium chloride triphenyl phosphine, PPS3 thrice. Rhodium chloride triphenyl phosphine, PPS3 thrice. So you can write here. So the first catalyst that is rhodium, here you can write rhodium chloride, this is your PPS3 thrice, this is your PPS3 thrice. So this is the metal atom and these are all ligands. So this is the organometallic complex which is used for hydrogenation of alkenes, for hydrogenation of carbon-carbon double bond. So this is used for hydrogenation of alkene, that is carbon-carbon double bond. It is used for hydrogenation of alkene, rhodium chloride triphenyl phosphine. So this is an example of organometallic complex, that is catalysis by organometallic complex. Let us see the another example of this system, that is catalysis by organometallic complexes. So there are different systems. First, that is acid base, then enzyme catalysis, metal atom, organometallic. So we are very much interested in organometallic catalysis, that is catalysis by organometallic. So first example is rhodium chloride triphenyl phosphine. Second example is the cobalt complex, that is dicobalt octacarbonyl. So it is used for oxo process, conversion of alkenes into aldehyde. So conversion of alkenes into aldehyde. So this is used for conversion of alkenes into aldehyde, oxo process or hydroformylation, dicobalt octacarbonyl. Okay, another complex, organometallic complex of rhodium, that is RH, HCO and PPS3 thrice, it is used in oxo process. So these two catalysts, that is dicobalt octacarbonyl and rhodium complex of HCO PPS3 thrice, are used for oxo process, that is conversion of alkenes into aldehyde. Another example of this homogeneous catalysis system is the rhodium complex, that is RH, CO, iodine having -1. So this is a rhodium complex. Rhodium is in +1 oxidation state and it is useful for carbonylation reaction, that is conversion of alcohol into acetic acid. So conversion of methanol, CH3OH, or insertion of CO, that is conversion of ethanol into acetic acid, and this process, it is known as Monsanto acetic acid synthesis. This process is called as Monsanto acetic acid synthesis, that is conversion of alcohol, that is insertion of carbonyl ligand into this methyl alcohol to get acetic acid. So for this reaction you have to use this catalyst, rhodium complex, organometallic complex is used for conversion of this alcohol into acetic acid, that is Monsanto acetic acid synthesis. Then if you replace this rhodium by iridium, that is iridium, here CO, 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 okay, CO, CO, I and having minus 1 charge. So just you have to replace the metal atom, that is rhodium is replaced by iridium. This catalyst is also used, this catalyst also used for carbonylation reaction, that is insertion of carbonyl to this alcohol CO to gives acetic acid. But the process is not a Monsanto acetic acid synthesis, it is known as a Cataiva process. Cataiva process. This is your Monsanto acetic acid synthesis. Monsanto acetic acid synthesis. This is your, if rhodium is replaced by iridium, then the process is known as Cataiva process, and it is also useful for conversion of this alcohol into this acid, conversion of alcohol into acid. This is known as Cataiva process. So keep in mind, that is rhodium complex, Monsanto acetic acid synthesis, iridium complex, Cataiva process. Dicoupled octacarbonyl rhodium complex used for oxo process, conversion of alkene to aldehyde, conversion of alkene to aldehyde. In previous example we studied the rhodium complex, that is rhodium chloride triphenyl phosphine. It is used for what? Hydrogenation of alkenes. So these are all the example of homogeneous catalysis, that is catalysis by organometallic complexes. So this is the important system of homogeneous catalysis, that is catalysis by organometallic complex. We are very much interested in organometallic complexes. So let us see the next point, that is the steps which is involved in organometallic complexes. So these are the systems, okay, so in which organometallic system is very useful in homogeneous catalysis. So what are the different steps which involve in this organometallic complexes? Organometallic complexes, that is catalysis by organometallic complexes. So which are the steps which is involved? First, that is oxidative addition. Oxidative addition, we already discussed it. Oxidative addition, in oxidative addition, oxidation state and the coordination number is increases by 2 units, okay, and then 16 electron species is converted into 18 electron species. Oxidative addition. Second, reductive elimination. Second, reductive elimination. Third, insertion reaction. Insertion. Fourth, beta hydride elimination reaction. Elimination reaction. So these are the all reaction are involved, or the steps are involved in organometallic in homogeneous catalysis carried out by organometallic complexes. Oxidative addition, reductive elimination, insertion, beta hydride elimination are the steps or the reaction which is involved in the catalysis system, that is homogeneous catalysis system, by using organometallic complex. So with the help of organometallic complex, these are the reaction which is involved in the conversion of reactant into the product, that is conversion of reactant into the product. So these are the important, we already discussed all about this. In next lecture we will discuss the applications or the advantages of homogeneous catalysis over heterogeneous catalysis. What are the advantages of homogeneous catalysis over heterogeneous catalysis? So you should keep in mind. So there is a different types of systems, homogeneous catalysis system, acid base, then enzyme catalysis, then metal atom, then porphyrin system is also there. But the most important is the catalysis by organometallic complexes. So catalysis of organometallic complexes involve these steps: oxidative, reductive insertion, beta hydride elimination. So we will discuss the example, that is rhodium complex, then iridium complex, which uh, with the help of this complex we can convert the reactant into the product. So in next lecture we will discuss the advantages and application of homogeneous catalysis, and we will discuss some catalytic cycle by homogeneous catalysis. Thank you.